So I've had a question on how to find annual returns out of monthly data when we're looking at Yahoo. And that's because they give you adjusted closing prices every month, but they don't give you an annual option. It's really just a matter of deleting and then calculating. So Yahoo Finance to your company, in my case Hershey's, historical prices. I'm going to do March to 2005, monthly, get prices. Then you scroll down and download. Okay, so here it comes. What we're going to do, first step after downloading, is to delete everything that's not adjusted close. Right? And then we're going to delete everything that's not March. Right? So for instance, I'm going to delete all the data from February, from April to February, right? And then I'm going to delete April to February, basically every single year. And when we get done here, all we're going to have is adjusted closing prices, or all we're going to have are adjusted closing prices for March of every year. If you're wondering what I'm doing to highlight multiple sections, I highlight them and then I hit Control, and with my finger on the Control key, I highlight the next section. And it doesn't matter if you make a cell bigger, like I just did. Es no importa. Okay. All we're left with is March of each year. There's an easier, maybe, depending on how you look at it, way, right? If you're back at this website, or I'm sorry, this page, you can download it. It's going to come down. It looks like this, right? It's the same exact data. Delete, right? And then I'm going to highlight what I need, Command Shift down arrow, and I'm going to go to Filter. And I'm going to filter by cell value. If I click on Filter by cell value, everything disappears, right? But you don't worry. You just come down here and you say, how do I want to filter it? By color? By what it equals? No, I want to filter it by March. March, okay. Got it, March of every year. There it is. It's a lot quicker. However, you can see everything else is just hidden. I like to just paste it in there and then delete these. You're going to have to actually delete it twice. Watch, I delete it once and then it just pops up. Ooh, I'm downloading the new software to make videos because the university's phasing this one out. Let's hope it doesn't actually open. So here we go. This is date. This is adjusted closing prices. And then here we're going to get annual returns. And this, of course, always, always, always HSY, annual returns, and variance, right? Because that's what we're looking at. So with annual returns, there, of course, there is one way to get the annual return each year, and that's by taking the new value, dividing it by the old value, and subtracting 1. If your data is old to new, don't look at up, cell on top, cell on bottom. Look at the newer divided by the older divided by 1. You can right-click in this corner, or double-click in that corner, turn it into percentages, give yourself 2 decimals, and then get rid of this divided by 0 error. Then we can get the arithmetic average, right, by just using the average formula. And we can get the geometric average by taking the newest value, dividing it by the oldest value, and raising it to the 1 over the n minus 1, which in this case is 10. Subtracting 1, roughly it looks like 7.5%, 7.75%. There you go. The last thing the homework assignment asks you to do is to calculate the variance and the standard deviation. And the way the text has it is it wants you to use the VARP function. So we'll look at the variation of our returns, and then we're going to look at the standard deviation, STDEVP, of our returns. That would mean that this was the population, not just a sample, which looks like a sample to me, but I'm not in charge. Okay, there we go. Standard deviation variance, 0.04. Standard deviation, I usually put that in percent because it lets us know that were this a normal distribution, we could expect a return of 7.75% plus or minus a standard deviation of 21%. Right, that's a pretty large standard deviation. And then if we take that fact in conjunction with the fact that stock returns aren't normal, right? They've got really wide distributions. So a normal distribution has, regular sized tails, but these have long tails, which mean that very low returns and very high returns happen much more frequently than do, let's say something that is normally distributed, like maybe shoe size, right? You see small shoes and you see big shoes, right? Big feet, small feet. But if shoe sizes were like stock returns, many more people would wear size 3 in adults and size 15 in adults. You'd see some people walking around with some pretty big feet if shoe sizes were like stock returns. Anyway, happy calculating, and as always, let me know if you have any questions.